So welcome to the presentation on how industrial waste heat can be used in district heating networks. And yeah, I'll give you also some insights on effective project initiation and business models. Maybe I'll shortly introduce myself. My name is Gabriela Jauschnik. I'm a research associate at the Energieinstitut at the Johannes Kepler University in Linz in Austria. And I've worked on the content of today's presentation in cooperation with my colleague, Simon Moser. So first, I'd like to introduce you to the motivation and the projects of today's presentation. Well, the energy transition needs to target not only the electricity sector, as we know, where the focus often lies, but also on the other significant energy-consuming sectors that still heavily rely on fossil fuels, such as the heating sector. And here, industrial waste heat can be a valuable tool in the decarbonization of the heating sector, but unfortunately, a significant share is still released unused into the environment. And there definitely are barriers to industrial waste heat utilization, but our research indicates that in Austria, there already is a large number of such implementations. And with the national research projects, Industrial Access Heat and Heat Highway, we on the one hand determined and evaluated the Austrian waste heat potentials as completely as possible. And on the other hand, investigated interregional heat transmission networks. And the results and insights that we gained in these projects provided the basis for our open access research paper, which I will elaborate in more detail in today's presentation. So in order to determine the success factors and the business models of industrial waste heat corporations, we conducted an Austrian-wide survey. And in previous research, my colleagues, Moser and Lassacher, searched for already implemented waste heat corporations and found 45 best practice examples that could later on even be extended to 51. And in this figure, you can see the map of Austria in dark gray, and the little black triangles represent already implemented waste heat corporations. And yes, we can also see that they are especially located in industry-dense areas. Moving on to the survey, we contacted the industrial waste heat providers that were identified in previous research, and we sent out the survey via mail in the form of a text document, and we collected it roughly a month after. We reassured the participants that only the name of the responding company will be published and that further data remains anonymous. And yeah, well, in total, we received 24 responses. Then in the next step, we analyzed the survey results on the general information regarding the corporation, how the corporation came about, the technical and economic aspects, as well as risks and uncertainties. So let's have a look at the technical aspects. We found that the typical annual quantity that was transferred was around 80 gigawatt hours with around 3,160 full hours. And the answers suggest that there are no minimum economic sizes. And this stems from the fact that we saw that the average capacity was at around 20 megawatts, with, I think, 4 responses that have indicated that their capacity is 2 megawatts or even lower. Usually only one waste heat source is utilized to cover the base load of the heating network. And only in a few cases, there has even been a full supply of the district heating network with waste heat. The waste heat cooperation was mostly initiated by ambitious management or employees of the heat generating company. But of course, this statement is very one-sided as we have not surveyed the district heating operators. And I also want to highlight the role of third parties, like, for example, mayors or local councils, as they can be vital in driving such a cooperation forward. The idea of such corporations comes mostly from technical and economic factors. For instance, if there has been a new investment made, for example, in industrial processes or the district heating network, which in turn led to the identification of new heat potential. And around 1/3 come from good contacts on both sides, where there has been a good understanding and regular exchange and a high level of trust. So in this table, we analyze the correlation between good contacts and big changes for the implementation of energy corporations. And well, you can see 3 categories: current interest, long contemplated, finally realized, and persons known good contact. The third column shows on which side of the partners the big change has occurred, either on both sides of the partners, one partner, or none of the partners. Then the fourth column shows the average major change on a scale from 0 to 2, whereas 0 means that there was no big change driving the implementation, and 2 meaning there definitely had to be some sort of change. And well, if we look at the first category, current interest, we see that it is always associated with one big change at exactly one partner, and which in turn leads to the establishment of contact. And as the number on the average major change is 1, we also interpret that it's not necessarily required to have a big change to establish contact. In the next category, it's the case where implementation has been pursued for some time and the feasibility has already been analyzed. And here we interpret that there definitely has to be a massive change to finally achieve implementation. And lastly, we found that implementations can also follow from good personal contacts and do not necessarily require major changes. Moving on to economic efficiency, financing, and billing. Well, the initial investments are mostly done by the district heating operator, or there is a predefined interface where the investments are split, for instance, through a transfer station. The billing is exclusively according to the consumed kilowatt hours and are mostly contractually indexed, for instance, to the consumer price index for electricity, gas, oil prices, etc. Then the waste heat, of course, cannot be free and is heavily dependent on different factors such as temperature, continuity, responsibility. And lastly, we found that the average amortization period is around 9 years. Through the results, we found that there is a standard case where boilers remain in operation at the district heating operator for the case that there are planned or unplanned outages. Regarding the business model, the customer pays a maximum of the costs of the avoided fuel use, and the industrial partner therefore receives a minimum remuneration for the heat, which depends on the alternative utilization. And the difference, which you can see in the figure on the right, where it's indicated in the spreading, the difference is then used to finance in a first step the CapEx and OpEx. So the project definitely has to be jointly profitable in the first step. And then in the next step, after the project is amortized, the distribution of benefits takes place. So in this figure, we can see the payment flows of a waste heat to district heating business model. We see the fictitious joint project account, where all the revenues are deposited and the expenses are withdrawn. So the income mostly comes from the heating company or exclusively, and yeah, they primarily save on fuel costs. And depending on the government, there can also be investment subsidies. The expenses include the CapEx and the OpEx, and compensation for the alternative use of heat. And after all the income and expenses have been considered, as I mentioned before, there is an economic surplus, which is then divided between the two partners. Regarding transparency, is very important that no partner should feel ripped off in the waste heat cooperation. And it is very important to build a high level of trust and also provide information, and that the partners are in constant exchange of information. Regarding the risks, the distribution of risk is essential, especially in such a case where high initial investments are involved. And well, these risks need to be clearly recognized and addressed by all the parties, as they are difficult to pass on in a partnership. And in such scenarios, those assuming fewer risks, of course, should expect to receive a smaller share of the returns, which reflects their reduced exposure and commitment. And regarding pricing, the risks are often hedged, such as by rights of first refusal and minimum quantity agreements, for instance, which is used to provide some stability and predictability for all the stakeholders. And well, it's important to establish clear interfaces for investments, billing and responsibility, to ensure smooth operations and transparent interactions between the parties. And here we have the same situation as before. Less investments leads to less responsibility and therefore a less share of revenue. Well, and lastly, here you can see a summary of the process for such a external waste heat cooperation. So, of course, in a first step, there has to be a basic consent of management after the initiation of contact. Then there is a preliminary agreement or letter of intent, which is then followed by the gathering of basic data, where there are internal calculations done, technical inputs collected, etc. Then in the next step, the technical and economic feasibility study is carried out, and different partners are involved and support secured. This in turn leads to the drafting of the contract, which is done by both partners together, and yes, in the best cases then signed, and well, the companies get then commissioned to build this energy corporation. Thank you.